were waiting. That question I posted. Marvelous, did you solve it? Were you able to solve it?
Stay there, please. I know my answer is no, please.
Hey, Nana Jemfua Edubia, were you able to go through that question?
I got the critical angle, but I didn't get the angle of the prism.
Okay,
I got something, but I'd like to confirm first.
Okay, so the angle of minimum deviation for a glass prism with refractive index √3. So we are told that the refractive index of the glass prism is equal to √3. So the angle of deviation of a glass prism for a glass prism with refractive index √3 equals the refracting angle. The angle of minimum deviation equals the refracting angle. And when there's a trick within the question. What is the angle of the prism? So the minimum deviation equals the refracting angle. And you are to look for this. Meaning that when you get the minimum deviation, you have the angle of the prism. When you get the angle of the prism, you have the minimum deviation. Please, are we okay?
Yeah.
Hello?
No, please. I thought the question says the angle of minimum deviation is equal to the refracting angle.
What did you say?
I thought the question says the angle of minimum deviation is equal to the refracting angle. But isn't A the angle of the prism, right?
It is. The angle of the prism has two names, either the angle of the prism or the refracting angle.
So then what is R?
Is that what is what?
R.
R is the angle of refraction.
So angle of refraction and refracting angle are different things.
If I draw a triangular prism, this is the angle of the prism, A, or the refracting angle. Then if I draw a normal, this is the incident ray. This is the angle of incidence. This ray would deviate towards the normal. This angle is R1. That's the angle of the refraction to the first plane, OA. Are you okay?
Yes, please.
So angle of refraction is different from angle of the prism. Angle of the prism is the same as the refracting angle of the prism. The refracting angle of the prism. Take note. Angle of refraction is different from refracting angle of the prism. Okay. So you are told that the minimum deviation is equal to the refracting angle of the prism or the angle of the prism. Are we fine? Now, the question is saying that find what is the angle of the prism, A. Once it's about minimum deviation, then I can say that sine of sigma m plus A all on 2 over sine of A on 2 must be equal to the refractive index, because the question is about minimum deviation. Please, are we okay here? So, because...
Mr. Dia, please take that part again.
This is refractive index pertaining to conditions of minimum deviation. This is the refractive index. Okay, pertaining to minimum deviation, which we've done before. Now, minimum deviation equals A. So I can say that mu is equal to sine of A plus A all on 2 divided by sine of A on 2, or mu is equal to sine of minimum deviation plus another minimum deviation all on 2 divided by sine of minimum deviation over 2. Any of this can apply because this is equal to A. So this is equal to A is equal to that. So whichever way you look at is correct. Please, are we okay?
Yes,
Are we
please.
okay here? And don't forget, you have this root of 3. Okay. Since there are a lot of sigma m and a lot of letters, let's stick to A. Let's stick to the first formula. Marvelous. Marvelous. Is she gone? So it means I have the numerator 2A over 2 over sine of A over 2. Now look at what is into the bracket. What we have within the bracket, so please, is 2A over 2. And so this 2 can cancel because Nana Jemfua, that is within the bracket. It's like 2 times angle of 30 divided by 2. The 2's can cancel within the bracket. Are you okay?
Yes, please.
Good. So the numerator gives us, we have root of 3 is equal to sine of A over sine of A on 2. Nanajo, are you there? Akofala, Deborah,
Yes,
and the rest? Okay. So are you okay?
Yes,
Now,
please.
meaning I have to expand sine A. But you know, sine of A is equal to sine A on 2 plus A on 2. Correct? Because A over 2 plus A over 2 would give me A. Half plus half is equal to 1. So I can express sine A as this. Please, are we fine?
Yes,
Are we
please.
okay? Physics and maths, they are related. So if you can apply maths, then your physics must also be good. So if this is it, then root, let me change the marker. Then root of 3 is equal to sine of half A plus half A, or A over 2 plus another A over 2. I think that will be simple. A over 2. Marvelous, are you there? Adelaide, are you there?
Yes.
Over sine of A over 2. Okay. From here, we use what we learned in trigonometry, expansion of compound angles, to expand the numerator. So the numerator would give us sine A on 2 cos A on 2 plus cos A on 2 times sine A on 2. Since multiplication is commutative, this will simply give us 2 sine A sine A on 2 cos A on 2.
Mr. Adria,
Hello.
please, I don't understand how we had the sine A on 2.
Where? Here?
No, please.
Where? Are you okay with this part? This part?
Yes, please.
Oh, okay. Then all that I'm saying is that this, okay, x times y is the same as y times x. So if we have sine A over 2 times cos A over 2 plus this time cos sine, then because multiplication is commutative, this part is the same as this part. So sine A on 2 cos A on 2 plus, I can bring the sign first, sine A on 2 cos A on 2. Because multiplication is commutative. Okay, so it's like the same thing being added to the same thing. So we have 2 sine A on 2 cos A on 2 as we used earlier. Are you okay?
Yes.
Good. Then, so this is root 3. The numerator is this, all divided by the denominator, which is sine A on 2. Now, all these are multiplying, so this can cancel out this. So we have 2 cos of A on 2, root of 3. When you divide through by 2, we have cos of A on 2 is equal to root of 3 on 2. Okay. The angle part, which is A on 2 would be equal to cos inverse of root of 3 on 2. Please, what is cos inverse of root of 3 on 2? Calculate that for me quickly.
30.
Pardon?
30.
30. So we have A on 2 equal to 30. If A on 2 is equal to 30, then okay, then the angle of the prism is equal to 30 times 2, which is 60 degrees. Yeah,
Mr.
So
Adria, please, can you take a picture and send it to the group?
I've been calling you without a name. Where did you go? You want to eat? In fact, this question is a little bit brain twerking, but it's good to be exposed to this kind of questions. Okay, when you solve this kind of question, when you get what WASSCE 2022 came, you just be laughing. So I've sent the solution into the group, okay?
Thank you.
Please, I hope it's Nanadwa and Co. I hope the solution now
Mr.
makes sense.
Adria.
I hope the solution now makes sense to you.
Yes, please.
So it's not so difficult, but you have to be exposed to it before you can apply, okay? Anita,
Yes, Mr. Edia.
are you on a rock?
Huh?
Anita Rosin, are you on the rocks? Anita doesn't understand proverb. Okay. So as I said, I have posted a lot of challenging questions on the platform. Dromo, Adley, Hannah, make time to look at it. Evia Bogua,
Mr. Edia.
are you okay?
Yes, please.
So what you have to do is that to all of you, what you have to do is that at your free time, just go through these challenging questions we have solved. We've solved about 2 challenging questions. Then pick any question, similar types or questions of less difficulty. And you realize that those ones whose difficulty level isn't high will be easy because you've gone through something like this. Are you okay? So that is why personally, when I'm teaching, I love giving challenging questions, because if you could get it, that will cure you. That will cure you. All right. Do I clean the board? Yes. Refraction of light in lenses. Lenses. So we've done refraction. Let's look at refraction in lenses. I think we've done prisms, refraction of light in rectangular and triangular prisms. Let's look at lenses. Let me show you one of the lenses. I have one of them around. This thing is what we are calling as lenses. Okay, and this is what is used in making the glasses. Those with eye defect, long-sightedness, short-sightedness. These are what is used in making it. Okay, so we are looking at refraction of light in lenses. An example is what you are seeing. And this is what you also use mostly in your practicals. Mirrors are used, but usually optics, light experiment generally goes with lenses. So refraction of light in lenses. So a lens is an optical device that refracts the path of light. It also refracts, just as triangular prisms and rectangular prisms does. This also refracts. So lenses also deviate the path of light. Now, let's look at the various types of lenses. Types of lenses. We have one, what we call as a biconvex and a biconcave lenses. Then we have plano-convex and then the plano concave lenses. Then we have convex and concave meniscus. If you hear by, then it means two. The by as used means two. If you hear plano, one, here it applies to one something. Convex, concave, meniscus. We know the meniscus of water, meniscus of mercury. So you understand. This kind of lens I have here is biconvex. Bi because we have two refracting surfaces, this side and this side, meaning that when you incident light here, it will deviate when it is coming out from through this end. Its part will be bent. You can also incident light at the other end, and when it is coming out through this end, it will deviate. So we have two refracting surfaces. So this is what the bi thing means. With the bi, we have. Come again. Hello.
Please, you've cleaned it.
Oh, don't worry. We'll come to it. Don't worry. So this is biconvex. I'll later explain to you why this is convex. And then this thing, this shape, I want it to be beautiful. So this is biconvex lens. This is biconcave lens. Let us understand why this is convex, why this is concave. I'm going to clean it. Okay, let me use this side. You see, let's compare it to mirrors. With mirrors, if we are talking about concave mirror, Adley, what is concave mirror? Can you describe concave mirror a little bit?
Concave mirrors have their reflecting surface inward.
The reflecting surface. So curve inward.
Curving inward.
And then the coated surface is outwardly, right?
Yes.
So with mirrors, this is concave mirror. This is a reflecting surface. Then this side is the coated surface. Then when you come to convex mirror, the same shape, but this time, this side Okay, I can even draw the same thing. The same shape you see here. But this time, this is a reflecting surface. This is the coated surface. So if it's a spoon, if you're looking at it from where liquids are put into, it is concave. When you turn the other way around and the back is a reflecting surface, is convex. Please, are we okay? When it comes to lenses, let me use by. Let's buy. For now, we don't know what it is. But this bulged out surface or surfaces point to the refracting surface. There's one refracting surface. This is another refracting surface. How would you describe these refracting surfaces? Are they curved outwardly or inwardly? The refracting surfaces, do they curve inwardly or outwardly?
Outwardly.
So they all curve, this one and this one, they all curve outwardly. Because they curve outwardly, it takes the name of this one. This is convex mirror because the reflecting surface curves outwardly. And so this is biconvex lens. It is convex because the refracting surface curves outwardly. Please, are we okay? Are we okay?
Yes.
Now, and this is biconvex. The other one is the plano. The plano has one refracting surface. Okay, so if you see a straight side and then a curved side, the plano has only one refracting surface. So we call this as plano convex lens. Then let's look at the other type. We have another one whose refracting surfaces, the bi curves, okay, inwardly. So this one, this one of it, there's the refracting surface. This is another refracting surface. And because the refracting surfaces this time curves inwardly, we call this as biconcave lens. Biconcave lens goes with concave mirror, where the refracting surface curves inwardly. Here too, the refracting surface curves inwardly. So biconcave lens. This is plano concave lens. Are we okay? Are we fine?
Yes, please.
Now, convex lenses are also known as converging lens or lenses. A convex lens, which is this, is also known as converging lens because if you incident light at one of the refracting surfaces, and are you there?
Yes, please.
Oh, okay. So when you incident parallel beam, what you you will call as parallel beam to one side. If you've seen a hand lens before, you have a convex lens. So this is a convex lens. Okay. When you incident, oh, I wish I have streams of light so I can incident it here. I think I'll look for videos for you. When you incident parallel beam at one side, they all converge at a point at the other side of the mirror. So this ray would refract. This ray would also refract and then come to this point. This ray would also refract, intersect at this point, and then this one would also meet here. So all for convex lenses, rays that are parallel and close to the principal axis all converge in front, behind, or at the other side. So that is why convex lens is also termed as converging lens. For concave, let me draw one. For concave lens, this is the principal axis. When you incident parallel beam of light, when they hit it, what happens is that, yes, this lenses refract. So when this ray is coming out, okay, its path will be deviated. This will also deviate. Once this hits the lens, the pole of the lens, it goes undeviated. But this will also deviate. If there's another one, this will also deviate. But always the deviated rays appear to be deviated from a point behind the mirror, the lens. So this is incident. This is refracted. You see, the refracted rays are diverged. They spread out, but they all appear to be diverted from a point. We'll come to the technicalities. So this is the reason why concave lenses are termed diverging lens, because they diverge beam of light, spread out beam of light. Are we fine?
Yes, please.
Please, if you are drawing, quickly do so, then let's continue. If you are done too, then let me clean the board. Do I?
Please. Please, another.
Eh?
Please, no.
Okay, hurry up. Are we through? Are we through?
Yes, please.
Okay, then let's talk briefly